Good morning, everyone. Good morning. Welcome back. Hope everyone is doing all right. Great to see everyone again. So this is an interesting topic for me. I've recently had this on my mind for the past week, I suppose. And I thought, I've tried to get it down on paper while it's still fresh in my mind. I say, get it down on paper? Get it down on computer while it's still fresh in my mind, because I know I'll be using this a bit going forward. What's the topic of today? I was recently looking through a list of looking at some old atlases featuring historic world maps. This doesn't quite tell the full story. The Earth is this 3D sphere, or nearabouts. But an atlas is a 2D object with the 3D, as best it can be, projected onto the 2D. So what was the problem here? So the curvature of the Earth distorts the detail, and the relations between cities is not quite captured. So we need a means to preserve the angles, the distances, the relativity, etc. And so this is where the topic of today's discussion comes along. This is stereographic projection. It's a challenge that navigators, sailors, traders, explorers, travelers, etc., for time in memoriam have tried to grapple with from the time of the Romans, the ancient Greeks, etc. In the 18th century, Leonhard Euler, 1707-1783, and Carl Friedrich Gauss, 1777, I think, to 1855, they were the ones who pioneered this subject. They were the ones that laid the groundwork and put all of these formulations into practice. So with their work, they've laid the foundation for cartography, map making, navigation, a bit more formal. And what stereographic projection is a means by which we can project three-dimensional space onto two-dimensional space. So that is, what does the globe look like on a map? So it can be generalized upwards. We can deal with 4-dimension, 5-dimension, and etc. However, that's a bit too advanced to me, and I think it's a bit too advanced for programmers C#. Well, I don't know. I suppose it's limited by my ability to give it information or build a script for. So let's stick right now with 3 dimensions, collapsing it into 2 dimensions. So what does that look like? Let's go over here to Google. So if I take this image here, and to the owner of this image, please don't write me up. I'm simply using it as reference, but I think it's a good reference, so thank you very much. This is the Earth here, the sphere, and this is the map below it, the square. So each point is going to be mapped onto the paper. So there's a bit of an issue here with trying to capture all of these points, because bear in mind, the projection that you can see, these dashed lines, will cut through 2 pieces. So the North Pole and whatever piece we're actually concerned with. But if we make that projection point slightly higher, we get into sort of more problems. One, because I found it was quite difficult to actually increase the projection point above the North Pole. Forgetting the fact that the Earth is at an angle of inclination of about 23 degrees or something. Forget that. I had to make some assumptions here. So if we put it at the North Pole, we sort of eliminate one problem of having only the North Pole and whatever projection, or the through point, I suppose, that the paper goes through. So that's interesting, and what we want to end up with is something like this. That looks roughly 2D, same as this. Again, please don't write me up. I'm using this as reference. Thank you very much. So let's get on with it. I want to try and write this out. For reference, this took me a few days or something to figure out and to type out. I'm hoping I can do it in 13 minutes. 30 minutes. Let's see. It's what is it? It's July 21st today, Monday. Let's get on with it. Let's see what we can create. So clear the board. Let's get on with it. So system, and I'm going to use the system collections. Genetic. So class, let's build that program. Okay, so what's in the program? Let's create the points. So bear in mind, we're working with 2 spaces, 2 sets of coordinates. What are they? Stereographic and the Cartesian coordinates. Okay, project double X. Let me write this out and I will elaborate in a minute. Okay, just checking. Double Z. So bear in mind, the Earth, we're dealing with a sphere of radius 1. So we're going to be dealing with a load of points, basically with a lot of decimals. So the double is short for double precision floating decimals. Let me know in the comments. What it allows me to do is import a load of decimals, 0.10 decimals, 15 decimals. Again, someone in the comments can tell me what the limits are, but the double is useful when you're working with decimals. Okay, so that's why you will see it feature quite a lot. And so before I go into that, let me explain how the transformation actually works. So the 2D will be the U and the V. So the U will be the X coordinate scaled down in proportion with Z. Similarly, the V coordinate, which will be the proxy for the new Y coordinate. And that's what they are. This is what the mathematics is. So very simple formula. We need a way to output this or produce it in the script here. So let's do that. So let's first define the denominator, because we can't solely define the denominator. We need to have a check in place, or failsafe, in case we have a singularity. So if the denominator is equal to 0, we have problems. So we can't allow that, which is why we have this one check, which will allow us to catch whether that denominator is equal to 0. So we can allow a few things, but we cannot allow it to be equal to 0. So we can allow it to be close to 0. Okay, and so now what happens if it is equal to 0? Give me a warning, right? So throw new, whatever it is, call it an exception. It's going to let me know that the point is too close to the projection point. It is undefined. Undefined. Okay, dot, close that, close. Okay, so, and let's write that out. What are we dealing with? So let's output that formula here. So x is the y over the denominator, x over the denominator, sorry, double that v coordinate will be equal to the y over the denominator, right? Okay, and what is it going to output? We need to output the stereographic projection, so u and v, okay? Do we get anything when we run this? Probably not, because we still haven't defined. Yeah, we need a main. Okay, so we need a point, and we need a means by which we can output that. So let's continue. New loop. Do I need a new loop? Yes, I think that goes before that. Yeah. Okay. So this they want a static main. Okay, let's give them a static main. So. Another loop there. Okay, so first of all, what are we actually producing here? Okay, let's give it a title for all this. What do we want the title to be? I don't know. It's the stereographic projection of how many cities do we want. The point is we're not going to output the whole map, but we're going to put a few cities, some major cities in the world on here. How many? I've written down. Let's call them 12. We're going to output 12 world cities on this map. Okay, so and let's put a line space between that. So make sure I'm still on track. The main probably isn't complete. The stereographic projection of the world with 12 world. The stereographic projection of 12 world cities. Great. So we're on the right track here. So let's add one city. Okay, so let's set up using the var function to create this thing called cities. And the cities will be a list of cities. Close that. Okay, what is this? So what will make up the city here? We need a name of the city. We need the country of the city. And we would want to define what those Cartesian coordinates are. Okay, so I don't need to close it off, but I do need to create a new list in here. So I have one city off the top of my head, and that is London. London is of course, in the United Kingdom. Okay, so, and I've written myself down here, and I've got a bone to pick here. I've got a point of contention I wish to raise. And after I put the coordinates down, I will tell you what that is. 2, 6, 8. Okay, so will I get my projection point here? Not yet, because I have a bit more work to do here. Oh wait, no, I don't have a bit. Great, that semicolon was a bit more work I had to do. For those of you who have been to London, who frequent the London Underground quite a bit and have visited or passed through East India on the DLR, would know that the Meridian line passes through the tube or the station. And don't take my word for it. There is a big line that cuts through. It's paved. It's tiled. I wonder who put it there. But that's where the Meridian line is. And so when you stand on certain parts of the platform, you'll be in the Eastern Hemisphere. On other parts of the platform, you'll be on the Western Hemisphere. Very cool. Check it out next time you're in London. So that's why I have a bit of a problem here. The majority of London is in the Eastern Hemisphere, so I was expecting a negative here. And my problem is going through a few more of these cities that I don't quite believe in these coordinates. Namely, for one, this x coordinate here looks a bit exaggerated. This is telling me 2/3 along the x-axis. But I see this across multiple websites, and so for right now, I'm simply going to have to trust them. But this isn't over. Okay, moving on. All right, moving on. We need a way to allow the console to link to these projections. So new, and I'm going to find that list again. String label. So now we want the projection. So we've defined the X and the Y, and we want to convert that to the U and the V. Okay. Okay, so still working? Don't get something wrong? Yeah, okay. Yep, okay, we're still on track here. Okay, so let's wind that loop. Good. So what did I press? Oh, I pressed the right. Okay. So now we want convert the cities, convert the coordinates, convert the coordinates. So that's what this will be for each city, which right now is only one, but bear with me. For each of the city that we created, the var, which we only want to simplify this with, we want to remove the strings because we've already defined them. Okay, in cities. So to find this now, what is actually going to be outputted? We only want the U and V. Wait, no, we don't. We want to calculate the stereographic projection, the stereographic points. Okay. So this will, in a way, it's going to link back up to this definition of the U and V. This is what underpins everything, that line 13 and 14. Okay, so X, X, Y, and Z, or Z, depending on if you're in the US. Okay, project, Sean's, add, okay, okay, I need to concentrate a bit here. How do I do this in my original? Okay, name. And I need the country. Okay, close that. And I need that to link up with the U and V. No, not you. Okay, I think this is still correct. Will you give me something? I don't think so. Yeah, okay, fine, because I haven't completed this. So I need to write this out. So what's actually going to be outputted in this console? Console right line. Okay, so I'm going to link that back up with U. So we call the I for each city. So the I, I'm associating an index to each city. So London is 1, for example. As I move through this, I'll get some more names, some more indices. Sorry, country, and that'll be closed. No, it's not going to be closed. No, out there. Yeah. Next, I want another console right line. So for each city, I want it to list the name and the country of where the city is. And I want to output the Cartesian coordinates and also the stereographic projection points as well. So sphere, what is this? X, Y, Z. Is that? Yep, go on. And so what else do I want? I want all of these points outputted. So the X to 5 decimal places, so F5. Y, semicolon. That's not correct. Oops, I'm going to have some trouble there. Okay, XY5. And Z as well. So Z, F5. Okay. I think that's good. It's not going to give me a problem. Okay. Console dot right line. Okay, and the same thing, but with the stereographic projections projected, U and V. Okay, so let's try that one last time. So U, F5, 5 decimal places. And V, also to 5 decimal places. Okay, cut that with a line, end that. And that should be it. I believe that's it. And this needs to run for everything, for all cities. Okay. So will this run now? Let's run that down a bit. No, what is it? The name Stereographic Projects doesn't exist. That's right. Stereographic Project, isn't it? Okay. No, the name Projections does not exist. That's right. Projection, sorry. Okay. Perfect. There we go. There's one city down. Okay. There's London. So that's all well and good. One is not entirely exciting. Well, I take that back. London is exciting. So that in and of itself will make this. Unfortunately, you wanted a whole series of points. So let me go and get some cities. I'll be back in 1 second. And I'm back. And I found these cities. I've got 12 there. Let's see if they actually run. Perfect. So what this is, I've gathered 12 cities here, as I promised earlier in my predefined line. London, Madrid, great city, Austin, and a few other cities in there to sort of space these out and give you some feel of how the map looks, let's say. So if I only had 1 point, it might not have looked that spectacular. But let's continue. So we've continued here. We've found the stereographic projections, which you can see here. This is the actual maths in the third line of each city. I have that one there, which is the index. I've outputted in the console the name, the country, the sphere. That's what all these things are. And the maths has already taken place as per this. This is the underlying maths. So that's all well and good. So let's see. The math is very good, but unfortunately we need to do something with this. So let's actually create a map. Let's see if we can make some sort of graph based on all of these stereographic projections. So what time is it? We've got 13 minutes if I want to stay true to that 30-minute mark. So let's see. Let's try this. Let's see how I get on here. Great. All right. Let's create the graph. Okay. So let's remind myself how I did this. We want to create this in the form of a grid with rows and columns. Okay, so what does that look like? I need to create a new loop. Okay, so below that, let's create the map. Create the map. So what does a map have, or a grid? Let's say they're going to pick here. They made me think about it as a grid, so I'm going to have to think about it as a grid with rows and columns. So let's say this has 60 rows and 60 columns. Not quite, but I'm going to tell you how we define those rows and columns. Okay, so what we're going to do next, I realize I couldn't do this quite any other way, but I'm going to define a dictionary, even though I've already defined a few lists. What is that dictionary going to be? It's going to simply recall the integer and the integer, which will be the U and V, which will be the row or the column of whatever the city is. And it'll cycle this through each integer that is the city index. So that's what the city grid here is, recalling those index points, which are the cities, London, Valletta, etc. So I need to concentrate here because I didn't the first time, and this is why it went on for a few days. I think it would have still taken a few days because I got this wrong. So I want to define a boundary, define the boundaries of this map. Otherwise, it's all well and good saying this goes from like, U from minus 100 to 100. If all the cities lie within a concentrated point of minus 1 and 1, then, well, problem. Or context lost, okay? So max U is equal to, I'll define what this is in a minute, was 5. And the max V is also going to be that small e to, or what is it? 5 decimal places of zeros. Okay, so for each var, I need to get some ambiguity here. So I'm going to use these underscores because I don't quite want the U and V as of yet. So from the projections now, I don't know why I'm using projections now. They gave us some attitude using projection, but for some reason this error sticks very, very, very sorely in me because I couldn't explain that. Math dot the max. Max U, and I will explain what this is. Okay, abs absolute value of u. Okay, and the max v is equal to math dot max. We'll do the same. Yeah, max v, or the math absolute u. V, sorry, don't get that right. So what this is doing, these are the boundaries. So the boundary is either, if your maximum stereographic projection is, let's say, for the U and the V, is this 1.939 here, or for, let's go to prior Cape Verde, Cape Verde, so 1.2703. If the absolute value is greater than 1.273, or close enough to 0, because remember the U can't be 0, no, the denominator couldn't be 0. Let's not work with zeros, okay? So the boundary would be the maximum of all of these points here for all the u's, okay? Okay, so let's continue. We'd found a boundary for this. What next do we need to do? We need, okay, how do we actually place the cities on the map? So I've heard that phrase a lot. In songs, politicians use it, singers use it, etc. My defining moment for putting a city on the map is me physically telling the script to do so. Okay, so placing the city on the map. Placing the city on the map, or the grid. I don't want to say the grid, it's a map. For each of these var indices, and this will be, might want to go back and check that things actually work here and see what my errors are. In projections, I will actually, let's see if I run this, I might not get, yeah, okay, invalid expression term expected. I'm just gonna have to come back to that. Okay, projections. So what is all this doing again? Let me just come back to it. Sorry, okay, integer of that u, and find that the u is the greatest of the two. Okay, I'm gonna need 2 times max u. Yes, plus 0.5 times the, that goes inside, oopsie, columns minus 1, okay, and I want to do the same. I don't want to risk a spelling error, so I'm going to copy that out again, but I'm going to do that with the rows. Okay, row is going to equal the same, but for negative v, 5 rows. Okay, so what does that mean? Okay, I say that, but I'm going to tell you what that means in a minute. Bar key equals row, or the column, that. So what this is doing, it's further defining the boundary of the map. So what this is doing is, it's in essence mapping U and V to an actual grid point. So we define the columns here in that grid 60. We're defining the bounds here further. So we're going to use that max U and max V here. So it's basically proportioning the U again within the grid based on the maximum values of U. So that's what this formula is here, and it makes a bit more sense on paper. So finally, we need to do something a bit more, because you'll notice that I've put a few cities in there, namely the two Americas, Seattle and Washington. Actually, I don't think they're that close apart. America's a big country. What else I have? I had Milan and Valletta, so they are very close by. So I'm going to have some problems if the stereographic map puts them too close together. So I'm going to have to put some sort of fail-safe in there. So what happens if the city grid is already occupied by something? Then it's going to have to. What's it going to have to do? It's going to have to. What's the word? Offset. One of them is going to have to offset and make way for another. Okay. City grid key. So there's really a lot of things going on here, and I'm not entirely sure. I probably made a lot of fat finger errors. Okay, but it's okay. I'm going to come back to this. So city grid key again. So you're going to add it next to it anyway. Okay, so add the index number, because bear in mind we only want the numbers to output it. I don't want it to simply say 1 London, United Kingdom. I only want it to say 1 on the grid. So I'm going to have an error here because nothing is falling into place. Okay, the name projection does not exist. That's right, because I didn't have the projections. Projection, yeah. Okay, so is that it? I think, yeah, okay, so projections in the business. No, you are correct. You are using projections. Okay. So this is the part where I'm gonna just go back a bit. Bear with me. Okay. It's fine so far. I say so far. Good. Okay. Okay. We're gonna have to go along with this for now because we need to print the map. Okay. So let's try and print the map first, and then let's see how we get on. So and see if I can actually cut this away. Will that still work? Yeah. So that's fine. What about you? If I get rid of you, is my dictionary still fine? Yeah. So you're fine. Double max. And you fine? No. In projections. Is it because I use projection or projections? There we go. I don't know why I'm saying that. So, oops, projections. So, yeah, okay. So, I think you're going to give me some problems now. So, projections, get rid of you. Good. Okay, so we're on track here. So, let's try and finish this off. So, let's print the map. Okay, so here we want to print the map. Print the map. So I've got 5 minutes left to make good on my promise here. Let's try. Console.WriteLine. Okay, and this will be stereographic projection. The stereographic projection. Stereographic projection. Okay. So that's going to be only a name to me. Yep. And close. Okay. Print map line, console write line, great. That looks like that. So let's finish this off. Okay, so int row starting from row equals 0. Row less than the number of rows which I defined earlier, and row plus plus. Okay, gotta be careful there. Gotta be careful there. So, and I also need to define this for the columns as well. Okay, so I'm going to copy that, I know, yeah, so for int row, and this will be col, for each column that is represented by an integer starting from 0, where the column is less than the number of columns defined earlier, which is still 60, or 40? 60, sorry, 60, yeah, okay, col that, okay, and now finish that loop. Ooh, okay, concentrate, come on, key is equal to the row or the column, so it's for running it for each row and each column, if the city grid, which we defined earlier, contains key, okay, we can continue. Okay, so the string, we're outputting the string. What is the string? It's whatever is defined by the name, the country that we said earlier. For each var, we need an index, and we're now defining what an index is in the city grid. City grid key. Okay, so so let me just give some run space there. What is the label? The label will cycle from anything within the index. Sorry, what is that? Dot, and we need to quote that IDX number again, the index. So the 1 for London, 2 for Madrid, etc. Okay, so that's all well and good. So the console.WriteLine, the label, we need those labels. Pad write. So let's offset this a bit. So let's indent this 5 digits or 5 places to the right. Let's have this start off. Okay, so that's 1 there. So what this is saying is that where there is a stereographic projection point, simply output it on the grid. Otherwise, we don't want this all blank. So what is going to be in place of it if it is blank, or if there's no projection point there? Let's fill this in by a string of ellipses. Oh, sorry, an ellipses, which is a string of dots. I will define that by 5 dots. And so I said earlier, we have 60 columns, 60 rows. So the rows are defined by these ellipses. So one column will be one of these ellipses. So I think that's it. Otherwise, we want to we don't want it to stop wherever we see a city or a projected city. So then continue to write the line beyond that. Okay, so will this run? I'm hoping this will run. Damn, we're so close. We were so close, lads. But everything was fine up until I printed the map. Good. Okay, so what is the problem here? Console right line. First thing, check if I've forgotten any semicolons or something. For each. Yeah. Okay. What about you? What if I? Oops. Okay, I've got 3 minutes left to finish this off. No, I don't. I'm already at 29. Okay. Concentrate. Okay, let me just read this through again. Console on dot the stereographic. N dot factor. That was fine. 4 in stereo. There's the word plus plus. We'll continue. Yes. Okay. So 4 int column equals 0 column less than the columns. Yeah. So the var key is equal to row col. That grid contains the big key capital K. Yeah, the string. God, that wasn't correct, wasn't it? No, it's you, isn't it? There. I'll close you off. No, okay, well, I mean, I should have closed that off anyway. Okay, so for each var idx, this keyword label plus equals the idx. No, it's you, isn't it? That's not right. You're telling me, yeah, that's problematic. Perfect. Okay, well, not perfect. Let's see what the grid looks like. No, okay. Okay, something's not quite right about the grid. We're getting there, So the console right line, label dot add right 5. Bear with me, sorry everyone. So right. Oh. For some reason I don't need a line. I don't believe I need that. That was it. There we go, okay. That looks sane enough to be correct, but that's still giving me a problem here. Console right line. Yeah, okay, yeah. I'm going to deal with that, or I'm going to allow that for now. So this is my stereographic projected map, and to make this a bit more seeable, I'm going to cut that down. Let's put that 40-40. Okay. Good. Okay. I'll work with that for now. So for now, this is what the map looks like. I was hoping that all these dots could fill themselves in, but not today, it seems. So here it is. We've got all these points. So where's London? London is here, closely followed by Madrid. That looks about correct. They are close together. What did I say? 3 is Austin, Texas. Yeah, is far away from London. Malta, is that Valletta? Valletta, Madrid there. No, what is it? 3 is Madrid. 2 is Madrid. I'm getting confused here. I can't remember what my points are, but you can see this is what the map looks like. I've simply tried to project it on this map. Let's run that through. So we took the Cartesian coordinates of the cities, London, the XYZ. We tried to project them onto the VY coordinate system in stereographic space. And then we needed to put that on a map. So there were a few steps to the map. Namely, we needed to define what the boundaries were based on what the maximum minimum UV were. And you can see that then sort of encased by a projection point here. It doesn't simply end with dots. So we defined the boundaries. We defined a means by which the cities can be placed on the map. And if cities overlap on the map, simply putting whatever that. Oh, that was a good example right there. See, we've got 4 and 6. I'll remind myself what 4 and 6 are. Valletta and Catania in Italy. They are very close together. They would have overlapped. That would have been a problem. But now I'm saying that's fine. We need another means to keep them together, so we've offset them. And this is the grid right here. Whew, okay, so well, that's it for now. I've realized this video's dragged on a bit, but I hope you understand. I hope you see what I've been getting at here. I'm going to try and fix this up. I'm going to try and find the actual coordinates here, because I'm still not happy about London and a few others. They look very off. If that's the way it is, then fine, I'll accept it. But for now, I'm going to make a part 2 of it. Consider this part 1. There were a few more things I wanted to do here, and I'm not entirely happy about this grid. So there are a few other things we can do here. So I'm going to go away, I'm going to have a think, and I'll come back later. But I hope you found this interesting. I hope you see what I've been trying to get at here. I hope you found this interesting. As always, if you have any comments, suggestions, thoughts, any criticisms at all, anything at all, let me know in the comments. Happy to address everything. For now, yeah, hope you found this useful. Hope you enjoyed this. And yeah, I'll be back with part 2 of this video. Stay tuned for that. And thank you very much. Enjoy your day. Yeah, we'll see you soon. Thank you so much.